Hey keyboard people, this is Brad from Brad Makes Keyboards. I'm doing a talkie video today. I'm going to show you how to desolder joints on a PCB, I'm going to go through a fast way to remove a switch, and also I'm going to wreck this board. That's right, I'm going to run this Instant Anti-Pro 2, and then I'm going to fix it and show you how. Let's talk about some of the tools you need here in order to have a successful repair. You don't need incredibly expensive tools for this kind of work, but usually the nicer you have, the easier of the time you'll have. Here I'm using a Weller soldering pump, model 7874B, proudly made in Taiwan. I've also got a Weller WLC 100 40-watt soldering station, which you can't see because it's off camera. And then I've just got this cheap brass sponge with a heavy base here to clean the iron up with. If you have a decent solder pump, you shouldn't worry about melting your tip with the soldering iron. I could probably melt this eventually if I tried, but there's no chance if I just touch them together for a second or two. That's important because you have to get the tip of your pump as close to the hot joint as you can to maximize suction. To use a solder pump, you need to press the plunger down until it clicks, and then when you push the button, a vacuum is created inside the pump, sucking any liquid into it. Now, mechanically soldered PCBs with through-plated holes like the one that we're looking at here can be tricky to remove solder from because the solder gets deep into the hole as part of the process. This isn't going to work so well probably, so I'll show you a better method after. I got a little of the solder out, but you can see there's still plenty in the hole at this point. Be aware that when you push the plunger down again, it may eject a little solder pellet from inside, so don't do it over your board. I'm going to try to heat up the remaining solder in this joint. At this point, I'm needing to put the tip of my soldering iron inside the hole. If you have to do this, then it's probably a good idea to start rethinking your strategy. This seldom does much other than scorch your pad because it will heat up the plating faster than it will the solder. Watch as it continues to not work well. It won't help in this case, but sometimes you can fill the hole with more solder and try again. Filling the hole back up gives you more surface area to heat up with your iron, and hopefully will allow you to melt the rest of the solder deeper in the hole. It's still not going to work here because we just can't get deep enough. These techniques would be fine for most hand solder joints, but we're having a hard time getting the deeper solder out of the holes. You may be inclined to apply more heat to the pad to get the lower solder to melt, but that's where you end up getting in trouble. I want to emphasize here that desoldering is an art, and sometimes takes different approaches for different situations. Now let's try something different that will get us some better results. I'm going to fill the holes back up again first because we will need to melt all of the solder well for this step. Put a switch puller on the switch you want to remove and clamp down on it and hold the PCB like this. Be careful not to mar up your plate. And do not tug or pull on the switch puller, but keep gentle pressure on the switch and alternate heating either solder joint with the iron up until... And here's our switch! You may want to clean the solder off the pins and bend them back into place if you're going to reuse it. Now, I will apply the previous method to remove the rest of the solder from the holes. See how cleanly the solder is pulled from the hole now that the switch pin isn't there to provide it with more surface area to stick to? Okay, now for the good stuff. Let's talk about carnage now. I'm going to destroy one of the pads for the H key we just removed, and then we'll repair it. A meter is handy for testing continuity. If it reads 0, odds are there's a direct connection between your two probes. You can identify a trace destination or troubleshoot a short this way. This top pad connects to the top end of that tiny diode right next to the LED. The other pad has traces on the other side of the board, so I don't want to burn that one out, otherwise I might have to remove every single switch to see where it went. So here's where we say don't try this at home. I'm just going to leave my soldering iron here for a few seconds until I see the pad melt into the solder. Wow, okay, this is taking way longer than I expected. Maybe if I stick the end inside the hole. Still trashing the board. Maybe. I'm putting some solder in there to hopefully spread the heat around more. I've never actually tried to do this on purpose. Don't let this put you off guard though. Lifting a pad is easy when you're doing it accidentally. Okay, I think I got it finally. Let me clean this up and we'll go in for a close-up. And there's the gruesome reveal. See, it's not shiny anymore? That means hosed, broke, kaput. So to fix this, we can attach a wire and connect it over to the diode and it'll work again, effectively bypassing the damage trace on the hole. I've put the switch back into the plate so that I can test fit the wire to the pin. There won't be anything holding it in place anymore for that one particular leg, but we have the other leg and the plate, so that shouldn't be a huge issue in this case. If we didn't have the plate, maybe some epoxy or glue of some sort might get consideration to keep a loose switch in place. That's a last resort kind of thing though, because it would make it much harder to remove later. Now the shape of the wire should be made as compatible with the board as possible before soldering. I'll go with a loop for the switch pin and a small bar for the diode so that I can maximize surface area. I'm going to spend some time getting it perfect here. The reason is because we don't want to stress the solder joints by bending the wire any more than we have to once we've started soldering. Unfortunately, my hands are doing a good job of getting in the way, but hopefully you can see here how I've got the wire bent to rest almost perfectly over the 2 points we want it to bridge. I'll adjust this a little bit later, but for the most part, it's where I want it. I'm starting to solder with the loop first. It's going to have quite a bit of surface area, so it'll be a much more secure joint than the diode end will be, so the odds of it breaking will be less. We need to put quite a bit of heat on this one to make sure that the solder flows and joins well with both the wire and the switch pin. If we don't get enough heat, then we could risk a cold joint, which would be bad for such a delicate connection. We don't need to worry about too much heat at this point, because the wire will sink a lot of it. Just doing a final test fit here with one end in place. I'm going to put a tiny blob of solder on the top leg of the surface mount diode, while my hat tries its best to block most of the view of the shot. You'll want to be especially delicate with surface mount devices because they tend to heat up faster and have less room for error than through-hole mounts do. I'm putting a blob there now so that I don't have to apply solder and hold the wire at the same time. Now I'm holding the wire against the diode so that the two ends meet, and I apply just enough heat to get the two to stick. I'm going to make sure that I don't have any shorts anywhere from that solder blob. Wire to wire is a direct connection, so that's not surprising. Now either side of the diode, I would expect a value here greater than 0, so that's fine too. Now the diode and the LED. Then I'll just check the other surrounding components to make sure everything looks good there. I still need to solder that other leg. I can do it the proper way though, since that pad is still intact. I'll overfill the joint a little, like how it was when I first opened it. And now to test it out, the moment of triumph. I'm just going to plug it in real quick and make sure that all the LEDs are lighting up properly. Just admiring our handiwork here a little. Now I'm going to pull up keyboardtester.com and make sure that the board is working properly. We want to make sure that not just the switch we replaced is functional, but all the other switches in that same column. Since we already have the board apart, it's usually a good idea to just test the whole thing while we're here. I'm going to flip it around one more time before I pack it up. This is my spare board and I haven't used it in a while, but it's filthy, so I'm going to take a moment and clean up the plate as long as I'm here. These are just Q-tips dipped in rubbing alcohol. I'm going to run them down the plate and get it looking shiny again. After this, I'll breeze through the reassembly by way of time-lapse. I'm planning on continuing my build series as commissions come in, but was this sort of video helpful too? Let me know if you have any feedback below, or if there's anything you'd be interested in seeing next. As always, this is Brad Makes Keyboards. Brad can make your keyboard too if you want. For more details, check out bradmakeskeyboards.com.